To recap, we started our discussion with nth order linear ordinary differential equations, where we had the 0th term, the first, all the way to the nth term. And we wiped out all the terms greater than the first, because we wanted to focus just on the first or lesser, being the 0th. So we got our two cases of first order linear, where we have the first term, or the first and the 0th term. And isolating for dy over dx, we would get this. Now, we saw that the solution for this was a simple integration, but for this, it was a little bit more complex. It was a process known as linear equations. And further, in addition to having a function in terms of just x, we multiplied a function in terms of y, and this was our case of separable variables. It was separable because we could separate the x's and the y's. But now we want to remove the function of x and just focus on the function of y. So we shift our focus to first order autonomous, the topic of this video. Now solving this is we just divide the hy over and we integrate, and this shall lead to this. Now in all of this, since hy is in the denominator, it cannot equal to 0, and this is the solution. Quite simple. Now, just as the solution for autonomous is simple, so too is visualizing this. To see this, let's take an example. dy over dx equals y cubed over 9 minus y. Right away we can see that it is autonomous because we recognize our hy. Now for a moment, let's just focus on y cubed over 9 minus y. Let's have it in terms of just f of y. We generate its plot on the left in addition to the slope field on the right. Right away we can kind of see a pattern where this curve right here, whatever its value is, that is the value of the slope, but at that y value, because the horizontal axis, the domain of this curve, is the y, but the vertical axis, the range of the slope field, is the y. So going from left to right corresponds to going from bottom to up. So think about it like this. Let's say if you focus from below -3, so from here all the way to -3, we see that the value of the curve is negative. So that is like focusing -3 here, but below that. Since it is negative, but getting exponentially more negative, the slope is going down, but getting exponentially more steeper. Similarly, if we focus from -3 to 0, we see that the curve is positive, so that corresponds to -3 to 0, we have positive slope values. And further, going with this, we can see the relation. 0 to 3 is negative again, going down, and then 3 to infinity is positive, but exponentially increasing, so slope going up, but exponentially getting steeper in that direction. And while at -3, 0, and 3, the curve is 0, so the slope is 0, -3, 0, and 3, horizontal slope. So that is the simplicity of visualizing autonomous, where we draw our hy as if it's just a curve, with the horizontal being the y-axis, and then we go left to right, and whatever the value is, we go, that is the value of the slope from bottom to up in the slope field. Now, one thing you may have noticed is that there are 4 regions: top, here, here, and then bottom. And this is caused by 3 separations: horizontal here, and horizontal here. And that has to do with the 3 intercepts: here, -3, 0, and then 3. So one other thing about autonomous is that however many zeros are in hy, in this case we had y equals -3, y equals 0, and y equals +3, that essentially determines how many regions there will be for our solution. Now let's go ahead and solve this. So we move over. We go ahead and separate the y's and the x's on each side. We integrate. We multiply the top and bottom with 9, so we can get rid of the y cubed over 9. Then we have this. Now we're going to go ahead and split the y squared minus 9. So we get this. Now we can see that this is a partial fraction decomposition problem because we want to split the denominator. So it can look like this, and it can be integrated. In order to solve for a, b, and c, we have to solve this equation, because the reason here is that this whole process is essentially the reverse. This process is what's happening in the numerator to get from here back to this. Because think about it like this. In order to put these denominators back into one denominator, you have to get a multiplied by all the other denominators, y plus 3, y minus 3, then b multiplied by all the other denominators, y minus 3, and then so on for c. So that's kind of like the process of partial fraction decomposition. Now how do we solve this? The way we do this is like this. We set y to a value such that it cancels out all the other constants, but just leaves the ones that we want to focus on. So first, we want to just isolate a, so we let y equal 0. By doing this, we see that our equation becomes this. We can see that the b's and the c's go to 0 and cancel out, so a becomes negative 1. Next, we want to get b, so we let y equals negative 3, and we get this. The a and c cancel, so we get b equals 1/2, and lastly, we set y equals 3 to get c, where now the a and b cancel, and we are just left with c, which becomes 1/2. Plugging in for a, b, and c, we get the following. Integrating, we get this. And then I want to multiply 2 on both sides, so we can get rid of the 1/2s. Alright? And now I will use the sum natural log property to combine these two, and then I will use the power natural log property to bring the 2 inside, raised to a power. So we have the following. Next, I will use the difference natural log property to combine these two into a quotient. So this becomes the following. I split the denominator, and then I also undid the natural log. That's why we got the c e to the 2x on the right. And then I undo the absolute value. But undoing the absolute value, you get plus or minus c, but then plus or minus c is just a constant c. So this here is our solution. Now we want to bring our solutions into the mix, so we go back to our curves. Where now we can have two cases, because we see that y squared is in the denominator, so we can have a case where y is less than 0 and y is greater than 0. So let's focus on the case where y is greater than 0. So we get the following curve. It's in the positive y side, since y is greater than 0. Right now c is set to negative 100. As we move c closer and closer and closer and closer to 0, we can see that it essentially becomes a horizontal line. But if we move it into the positive direction, our solution is on our topmost region. Okay? So just by focusing on y greater than 0, we see we can get our two different solutions for the case where c is positive and for the case where c is negative. But if y is negative, we get our other two regions, where now if c is negative, this is our third region, and if c is positive, is our bottommost region. Now if c equals 0, we essentially get y equals negative 3, this horizontal line. And similarly, if y was 0, then we would just get this horizontal line. Okay?